The aromatic and invigorating beverage, beloved by many as a daily ritual, has become an integral part of our lifestyle. With Earth's population consuming nearly 3 billion cups of coffee each day, it has truly become a global phenomenon. However, the production of coffee has brought about certain concerns, including detrimental effects on human and animal health that now weigh heavily on our conscience. Since the 1990s, coffee plants have faced a barrage of attacks from insects, bacteria, and fungi, largely due to their increased cultivation as a monoculture crop. These attacks have been further intensified by the effects of climate change. To combat these unwanted guests, farmers on larger coffee plantations have resorted to the heightened use of pesticides, their primary weapon of choice. In the case of Brazil, the world's largest coffee producer and consumer of pesticides, chemical pesticide usage has surged by an alarming 190% over a decade. Estimates reveal that approximately 38 million kilograms of pesticides are utilized annually in Brazilian coffee production. Adding to the concern, Brazil has approved the use of 475 new pesticides since 2019. Alarmingly, more than one-third of these pesticides are deemed unfit for approval in the European Union due to their toxic nature. Athena Catullias, a newly graduated PhD fellow at the University of Copenhagen's Department of Geosciences and Natural Resource Management, highlights the worrisome consequences of pesticide usage in coffee production. She asserts, the problem lies in the increasing reports of pesticide contamination in groundwater and ecosystems, as well as the emergence of harmful symptoms and disorders in animals and humans residing in coffee-growing areas. These include skin disorders, respiratory problems, high blood pressure, organ damage, cancer, and cardiovascular diseases. It appears that all these issues are closely tied to the use of pesticides. Dr. Catullias, along with Professor David B. Collins of the Department of Plant and Environmental Sciences and Associate Professor Anders Rabid of the Department of Geosciences and Natural Resource Management, conducted a meta-study published in the journal Plant Pathology. Their study reviews research on alternative plant protection strategies for coffee. The adverse effects of pesticides are predominantly reported in regions such as Brazil, Colombia, Jamaica, and Nicaragua, characterized by rich biodiversity, fragile ecosystems, and economically disadvantaged rural populations. Similar consequences driven by pesticides have been observed in studies from other countries. For instance, a study conducted in the Dominican Republic demonstrated a significantly higher incidence of cellular changes among coffee plantation workers exposed to pesticides. Dr. Catullias emphasizes the need to reconsider current coffee production practices for the sake of our future coffee consumption. She states, if we wish to continue enjoying our morning coffee in the long run, we must abandon the approach of producing it recklessly. Pesticides may provide short-term benefits by combating pests and plant diseases, resulting in higher yields for coffee farmers. However, in the long term, we are causing severe damage to ecosystems and compromising overall health. Restoring coffee growing to its origins. The researchers propose several sustainable alternatives to traditional chemical methods. One such approach is agroforestry, where crops and trees are cultivated on the same land. This technique would restore coffee growing to its original roots. The coffee plant originated thousands of years ago in a shaded environment filled with a diverse range of plants, shrubs, and trees in southwestern Ethiopia. This is the traditional way Ethiopian farmers grow coffee. It offers the advantage of minimizing pests and diseases while enhancing plant health, biodiversity, and ecosystems. Additionally, agroforestry diversifies farmers' income sources, as they can earn profits from both coffee beans and secondary farm products like wood, livestock feed, and other tropical cash crops such as vanilla or cinnamon. However, challenges arise when implementing agroforestry, as certain pests and diseases tend to thrive in such systems. Careful planning is required to determine the optimal combination of plants and trees that offer the most benefits to farmers. Decisions may involve considerations like whether to plant fast-growing banana trees or hardwoods that can be harvested for timber. Consequently, the cultivation method must be tailored to local needs. Although not a panacea, it is deemed the most sensible solution. The researchers also advocate for the expansion of biological control, which involves introducing bacteria, fungi, and insects as natural enemies to combat pathogenic organisms, thus reducing reliance on chemical pesticides. Another strategy highlighted by the researchers is a genomic technique called RNA interference. This cutting-edge method involves spraying RNA molecules onto crops to silence vital genes in target organisms that pose a threat to coffee plants. One notable advantage of this technique is its targeted effect on pests, with minimal impact on non-target organisms and the environment. Although RNA interference has been successfully tested on various crops, it has yet to be applied to coffee. The predominance of large-scale farmers is a major concern. Small-scale farmers, cultivating 70 to 95% of the world's coffee on plots of land typically less than 5 hectares, have generally refrained from using pesticides. Moreover, they already practice agroforestry to some extent. The main challenge lies with large-scale farmers, primarily located in Brazil and Vietnam, who account for a disproportionately high share of global coffee production. Athena Catullias asserts that the cultivation practices of these farmers pose a significant problem. This small percentage of coffee farmers is driving production in an unsustainable direction by favoring monoculture and excessive pesticide usage. However, by degrading the coffee-growing environment, they are endangering the very ecosystem on which the coffee plant depends, Catullias warns. In addition to investing in research focused on environmentally friendly genomic technologies, the researchers recommend providing support to farmers at the national or international level to transition to agroforestry or adopt other recommended strategies. Catullias concludes, farmers implementing environmentally friendly initiatives should be rewarded through compensation programs. Emphasis should also be placed on coffee roasters, importers, and other stakeholders in the value chain, encouraging sustainability programs that genuinely benefit the coffee plant, the cultivation environment, and the farmers themselves.